I'm Teacher Mayette, and we will discuss Mathematics 10, Quarter 2, Week 1, Illustrating Polynomial Function. Recall your knowledge on the concept of polynomial expressions. This knowledge will help you understand the formal definition of a polynomial function. Which is which? In this activity, we will identify if the expression is polynomial or not polynomial. First example, we have 14x. Is it polynomial or not polynomial? Okay, correct. Polynomial, since it has positive exponent, which is 1. Second example, we have 5x cubed minus 4 square root 2x plus x. Very good. Not polynomial because variable of one term, which is negative 4 square root of 2x, is inside the radical. Number 3, 1 minus 16x squared. Polynomial. It's because of the positive exponent. Next number, we have x to the power of 3/4 plus 3x to the power of 1/4 plus 7. Not polynomial because the exponents of variables are fractional. Another one, 1 over 2x cubed plus 2 over 3x to the 4th minus 3 over 4x to the power of 5. Not polynomial because the variables are in the denominator. And lastly, we have negative 4x to the power of negative 100 plus 4x to the power of 100. Not polynomial because the exponents are negative. Now let us analyze the findings that we have. So we have here 5x cubed minus 4 square root of 2x plus x. What is the reason why it is not polynomial? The reason, we have variable of one term is inside the radical. For x to the power of 3/4 plus 3x to the power of 1/4 plus 7, the exponents of variables are fractional. So another example why it is not polynomial is 1 over 2x cubed plus 2 over 3x to the power of 4 minus 3 over 4x to the power of 5. The reason is the variables are in the denominator. And lastly, negative 4x to the power of negative 100 plus 4x to the power of 100, the exponents are negative.
A function of the form p of x is equal to a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 plus a sub n minus 2 x to the power of n minus 2, so on and so forth, plus a sub 1x plus a sub 0, where a sub n should not be equal to 0, is what we call the polynomial function. So note that n should be a positive integer. The coefficients are real numbers like a sub 0, a sub 1, and so on, and a sub n. The leading term is a sub n x to the power of n. The leading coefficient is a sub n, and the constant term, as seen in the last form, is a sub 0. Now, to know more about these functions, we will introduce to you some examples to learn more about the leading term, leading coefficient, degree, and the constant term. Let's have an example of p of x equal to 3x plus 4. What is the leading term? Its leading coefficient, degree, and constant term. Okay, 5 seconds. So the answers reveals that the leading term in this linear function is we have 3x. So the leading coefficient that contains the leading term is 3. And we also have the degree of 1, which is the highest exponent of the leading term. And the constant term is 4. The number 2 example is an example of a quadratic function. We have 4x squared plus 15x plus 10. So give me the leading term, leading coefficient, degree, and constant term in 5 seconds. Did you get the correct answer? So we have the leading term is 4x squared with the leading coefficient, which is 4. So the highest exponent is 2 and the constant term is 10. Okay, number 3. We have here 4x cubed minus x plus 3. What do you think is the leading term, leading coefficient, degree, and the constant term? Let's reveal the answer. Check it out. The leading term is 4x cubed. We have the leading coefficient is 4. The degree is 3. And the constant term is also 3. The terms of a polynomial may be written in any order. However, if they are written in decreasing powers of x, we say the polynomial function is in standard form. Other than p of x, polynomial function, it also denoted as f of x. Here are some of examples of factored form of polynomials function that is written in standard form. The first one, y is equal to the quantity of y plus 2 multiplied by the quantity of y minus 5. So by multiplying these binomials, we can get y is equal to y squared plus 2y minus 5y minus 10. So you combine like terms and we can get y is equal to y squared minus 3y minus 10. As you can see, in this function, it is already in standard form since the powers or exponents is in decreasing order. Number 2 example, f of x is equal to the quantity x plus 7 times the quantity x plus 2 times the quantity x minus 4. To get the product, multiply the quantity x plus 7 and x plus 2. So through FOIL method, we can have x squared plus 9x plus 14 multiplied by the quantity x minus 4. So using the distributive property, we can get x cubed minus 4x squared plus 9x squared minus 36x plus 14x minus 56. So, you will combine like terms and you can get the final answer, which is x cubed plus 5x squared minus 22x minus 56. So in this example, it is considered a standard form since the exponents are in decreasing powers. For number 3, we have p of x is equal to x multiplied by the quantity x minus 8 times the quantity of x minus 2. Then, by distributive property, we multiply x times the quantity of x minus 8. So we can get x squared minus 8x. So again, through FOIL method, we can get x cubed minus 2x squared minus 8x squared plus 16x. Now, to combine like terms, negative 2x squared minus 8x squared, we can get negative 10x squared. So we will have now x cubed minus 10x squared plus 16x. So this considered already a standard form since the exponents of the given polynomial function is in decreasing powers. Complete the table and answer the questions if the given function is polynomial or not. The first one is already given. We have f of x is equal to 4x cubed plus 5x squared minus x minus 6. So since the exponents are positive, so it is polynomial. Then the highest exponent we have is 3. So the degree is 3. Now the leading term we have 4x cubed. This contains the highest exponent and the leading coefficient is 4. And lastly, the constant term is negative 6. For the second example, g of x equal to x to the power of negative 4 plus 7x cubed minus 2x squared plus 6x minus 1. Identify if the given function is polynomial or not. So it is not polynomial since it has negative exponent. So you don't need to write the degree, leading term, leading coefficient, and constant term if your answer is not polynomial. Number 3, p of x is equal to x cubed plus 3x to the power of 5 minus 7x squared plus 4. So identify if it is polynomial or not. So since the exponents are positive, so we can have polynomial. Now the degree is 5. It is the highest exponent. The leading term is 3x to the power of 5, which contains the leading coefficient, which is 3. And lastly, the constant term is 4. So try number 4. Y is equal to 8, y to the power of 6 minus 4y cubed plus 3y squared plus 9y. Okay, so I think you are done. Check out your answer if your answer is correct. So we got polynomial. The degree is 6. 8y to the power of 6, which is the leading term. Leading coefficient is 8 and the constant term is 0. For more exercises, we have here another table, and then you can fill in the table and give the standard form, degree, and the leading coefficient and the constant term. Just check your answer if it is correct, and thank you for listening, and God bless us all.